All right. So what does it mean for something to be consistent? It's got at least one solution. How about inconsistent? No solution. Independent. Exactly one. And dependent. Okay, infinitely many. All right. What kind of lines would be infinitely many? Yep. Lines that just keep going on top of each other. Okay, no solution. If they intersect at one point. Yep. All right. So, we're looking at page 156 for problems. Okay, graph and check. Okay, graph the linear system and estimate the solution, then check the solution algebraically. Okay, this is the ones where you do have to check it. Okay, these problems do specifically say to check it, so we are going to be checking them. If it doesn't specify, then you don't have to. But anyways, all right, let's start with number 4. My pen will write. So we have y is equal to 5x plus 2, and y is equal to 3x. Okay, and it might be easier if you have graph paper to use it. I'm just going to try to be really, really careful with my graph here. Okay, because we're graphing the two lines and finding the point of intersection if there is one. Yep. When else would you have watched it? Gotcha. Alright, so graphing the first line, where would it be? Okay. Alright, the other line then is where? So then I would go down 3 and back 1. Okay, and this technically is where it intersects. Okay, my graph's not drawn perfectly. Okay, it's one solution. Okay, this point here we're looking at is -1, -3. Okay, and we need to check it. So basically you can pick either of the above equations. I don't care which one. I'm only going to require you to check it in one. And we're going to just plug it back in. So y is equal to 3x. So -3 is equal to 3 times -1. -3 is equal to -3. Alright, let's see. Trying to get ones that aren't like crazy. 10 y equals negative 3x minus 13 and negative x minus 2y is equal to negative 4. So we will I guess I need to go down farther than I went down. Alright, so we need to modify equation 2, probably is the easiest way to do it. So I need to add x over and then divide by negative 2. So y is going to be equal to, let's see, negative 1/2 x plus 2. Okay, so I'm just going to cross that equation out. Yes. Quickly. Okay, so now I need to graph the top line. What does that look like? Okay, I'm just going to go there and hope that that's enough. And then the other one, well, this one was throwing me off because I thought I had enough dots and then I realized I don't, so now I have to go back up. Just kidding, that point's in the wrong spot. Up 1, back 2. Yeah, this is a lot easier with graph paper. That was a really bad line. This one looks like it would keep going, so somewhere in here. This one? Down to negative 13. I went up 3, back 1 because it's negative. I'm going to tell you, because these are so hard to line up unless you actually have graph paper, usually on a test or quiz I only give one of this type. Okay, and I give one that's relatively easy that you should be able to see pretty quickly. Because eventually we're going to do these algebraically, which is just a whole lot easier. But we have to do them graphically too. Okay, so this point would be negative 6, 5, okay, approximately. So we check it. So 5 is equal to negative 3 times negative 6 minus 13. So 5 is equal to 18 minus 13. 5 is equal to 5, which is true, so that point works. Okay, and like I said, I'm going to give you easier ones. Yeah, I would say if you have graph paper, use it, would be my recommendation. Okay, I'm just going to give you guys easy ones when I give you problems so that it shouldn't really be an issue. Okay. Alright, number 12. Not necessarily. Alright, so 12, y equals 4x plus 3, and 20x minus 5y is equal to negative 15. Do what with it? Wait and do that until you've moved stuff, and then do that. Yeah, move the 20 over first and then divide by it. So negative 5y is equal to negative 20x minus 15. Now I can divide by negative 5. So y is equal to 4x plus 3. It's going to be the same line, meaning what? Huh? Infinite solutions. I'm not going to make you graph that one. You don't check those ones. And if there was one that's no solution, which I don't think that section has any that are no solution, but if they were no solution, okay, kind of like, Garrett kind of said it earlier, you can look at the slope a little bit and tell what's going to happen. So if you had two slopes that were the same, and the y-intercept is different, they're parallel, and then you can say no solution. And you wouldn't have to show anything else. I'm not going to make you graph the two lines if they're not going to intersect. Really, the only ones you need to graph are the ones that you either can't tell, or the ones that you know, okay, they're going to intersect somewhere, I just need to figure out where. Alright, moving down to the next step, it says to solve the system and classify the system as consistent and independent, consistent and dependent, or inconsistent. Okay. Trying to decide how I want to do this because technically speaking, next section this will be a lot easier, but alright, let's look at 18. Do you guys remember how to solve a system by elimination or combination or substitution? That's the next section, so I was just curious. Okay. So basically, I'm just going to wait on that then. I thought you might remember it more, so we'll wait on that. So basically with these two, you're just going to graph them. You don't have to say where they intersect. You just have to basically say if they intersect or not, and if not, then what happens. So these ones will be easier to graph. Okay, so I should modify this top equation to be what? Okay, because there's a negative here. Okay, I'm moving everything over in one step. You don't have to move it over in one step. I'm just trying to save room. Okay, so I move it over, that's negative 2x, but then divided by negative is 2x, and then 4 divided by negative, negative 4. And then the one below it, subtract x, divide by negative 2. Subtract x, divide by negative 2. Okay, if you guys need to do this in more than one step, please do. Okay. Honestly, without even graphing, what do you see is going to be true of this? It's not perpendicular, but does that mean that they don't intersect? They do intersect. Okay, they're not parallel. They're not the same line. So right there, I'm going to save you the time and not even make you graph them. What does that mean? Consistent or inconsistent? Consistent, and then is it independent or dependent? It's independent. Okay, consistent and independent. Let's see. (28) 5 halves x minus y is equal to negative 4. 5x minus 2y is equal to 1/4. Probably not. Well, I mean, maybe, but we're not going to do it that way right now. That's not this section. Alright, I need to get y by itself, so what do I do to the top one? Okay, subtract 5 over 2x, but then I'm dividing by a negative, so it's going to be back to be positive. And then plus 4. For the other one, so what does that mean? The lines are parallel, so is it consistent or inconsistent? It's no solution, so it's inconsistent. And then is it dependent or independent? Or neither? Neither. Okay, if it's inconsistent and it's not independent or dependent, we just say it's inconsistent. Because inconsistent is no solution. Alright, how do we feel about this stuff? I know it's kind of crazy, kind of new. Okay, what I want to do, okay, there's only like 10, 12 minutes left in class. What I'm going to do is I'm going to give you like 4 problems. Okay, if you don't finish them, that's fine. Tomorrow we can finish going over this if you guys have questions. Okay, it's not homework. Okay, it's purely do it in class. But I would like to go over the stuff tomorrow to make sure we're understanding it before we move into the next stuff. Because I don't want us to be like lost on it. So, the problems, 156. Okay, graphing, I'm just going to give you 2 of them. Trying to give you some that are kind of easy. 3 and 5. And then (17) and 21. Okay. This section, While it is on the quiz and test, it's not as heavily tested and quizzed on. Okay, the consistent, independent, consistent, dependent, and then inconsistent does come up more frequently as well, like with later sections. So it's kind of just an intro to dealing with it with graphing. But just get through as much of it as you can during this class, and then we'll look at the stuff again tomorrow to kind of go over it and review.